Welcome to 4.3. We're going to talk about rotations. That's one of our rigid transformations. And I'm not going to really fill out this vocab. We're just going to get it when we hit the core concepts down below. So let's just keep going. So, rotation. What Big Idea says here is a rotation is a transformation in which a figure is turned about a fixed point called a center of rotation. So rotations, we turn things, okay, around a certain point. Our center in this class is going to be the origin, okay? And then if we could find how far we moved that angle from the original point to the other point, we drew like little rays from like P to Q and P to Q prime. This angle here, that's that angle of rotation. How far did we move? It's like if I drew a ray from P to R and P to R prime, that angle will also measure 40 degrees. So here are the rules, but I'm going to have us change these. I like to have rules with X's and Y's. So based on this diagram, if we want to do X and Y's, let's change our rotations. Now notice this says for counterclockwise. In this class, we will use the majority of time counterclockwise. And then my explanation is if we look at our quadrants, we go counterclockwise when we number our quadrants. And when you get into like your unit circle stuff, we'll use the quadrants and go counterclockwise. So let's just go counterclockwise to get in that habit. So let's talk about our different rules. If we have 90 degrees, I'm going to write it with our normal notation here. That is going to, we're going to have X and Y. And what happens is this now becomes right? It now becomes negative y comma x. For 180-degree rotation, your x and y just become their opposites. So negative x comma negative y. And then for 270 degrees, x and y get turned into y comma negative x. So I like it more with the x's and y's rather than the a's and the b's. So we're not going to do all of these down here, but let's do a couple of these. Let's go down to just trying these. So number one here on the side, I'm going to write down the original values of J, K, L, and M. So J is negative 2, 4. K is negative 5, 1. L is negative 2, negative 2. And M is 1, 1. Now let's find the prime version. So J prime, K prime, L prime, M prime. And we're going to apply our 180-degree rotation. Now that rule says if we have X and Y, it turns into negative X, negative Y. So that would give me, for J, positive 2, negative 4. For K prime, would give me positive 5, negative 1. For L prime, will give me 2, 2. And for M prime, it would give me negative 1, negative 1. So now I can go ahead and graph these. And so to graph them, I'm going to go to 2, negative 4. There's my J. And then 5, negative 1. That's going to be K prime. Sorry, put the prime with the J. Then 2, 2 would be L prime. And then negative 1, negative 1 would be M prime. And then I can connect these. There is my square rotated 180 degrees. Now let's just go ahead and I'm going to skip number 2. Let's look at number 3 here. I'm going to do the same process. I'm going to find A, B, C, and D. So point A is 1, 4. Point B is 4, 3. Point C is 3, 1. And point D is 1, 2. Let's go ahead and find our prime versions. Let's go and find those images based on the pre-image. And we are rotating 270 degrees. So the rule says if we have X and Y and we rotate 270, we're going to get Y negative X. So I'm going to swap them, but then make the X value its opposite. So I'm going to get 4, negative 1. I'm going to get 3, negative 4. I'll get 1, negative 3, and then 2, negative 1. Now I'm going to go ahead and graph these. 4, negative 1. There's my A prime. and then 3, -4. There's my B prime. 1, -3 is my C prime. And then 2, -1. There's my D prime. And there's my lovely quadrilateral. All right, let's see what we have next. Composition. Let's just do one of these. Let's just do number 5. So we're going to do the rotation first and the translation second. Again, I'm going to find what M and N are. So here's M and here's N. So M is -1. No, not -1. -2, -1. And N is 3, 1. Let's go ahead and do M prime and N prime. So this is a 90-degree rotation. So 90 degrees says we need to take our x and y and turn to -yx. So that's going to give me 1, comma, -2. And then let's see, what's the next one? That was 3, 1. So that's going to give me -1, 3. Now I'm going to do the translation. So now I want M double prime. Sorry, my iPad just went a little crazy. M double prime, N double prime. And I'm going to add 2 to my X value. So that's going to be 3. Subtract 3 from my Y value. That's -5. And for N, add 2 gives me 1. Subtract 3, I get 0. Now I get to graph these. So let's go to 3, -5. That's right here. That is going to be M double prime. And then 1, 0. There's my N double prime. And now I can connect these. So that would be a composition. Let's go to the next page. So we do the same thing with 6 and 7. And again, I'm not really worried about doing a lot of these because they're all the same. It's just practicing using those rules. Okay. But I will do is let's go ahead and do number 8, which is can we graph the original and then graph its image after the composition? So I'm going to quickly just do that. We're going to talk about J is 2, 3. K is 1, -1, and L is -1, 0. And then I'm going to do J prime, K prime, L prime. And if I look at this one first, this is supposed to be 180 degrees about the origin. So that just means you make everything as opposite. So I will get -2, -3. I'll get -1, 1, and then 1, 0. And then reflection over the X. So I have to figure out how far away is my X value in my first image to the second image. Sorry, let me say that again. How far away is the X value in that first image to that reflection line so I can find the X value in the second image? So when we're reflecting over a line, like X equals a number, one thing we know is our Y values stay the same. So in J double prime, I'm going to keep -3. K double prime, I'm going to keep 1. And L double prime, I'm going to keep the Y value 0. So now I need to think for X equaling 2, I need to think, how do I get from -2 to 2? I added 4. So if I add 4 again, I get 6. How do I get from -1 to 2? I add 3. So if I add 3 again, I'm going to get 5. Then how do I get from 1 to 2? I add 1. So add 1 again, I get 3. So let's go ahead and graph the pre-image and the image. So I'm going to go to 2. I'm actually going to count by 2. Yeah, again, I'm going to count by 2s just to make life easy. So let's call this like 2, 4, 6, 2, 4, 6 to make life easier. Let's see, 2, 3. Here's J. 1, -1 would be K. So here's J, here's K, and then -1, 0 is L. So this is our little triangle. Now I'm going to go ahead and graph the final image here, which would be 6, -3. There's J double prime. 5, -1, or 5, +1 is going to be K double prime. And then we have 3, 0, which is L double prime. And now I can connect these. Right, and the last thing is just rotational symmetry. Can we rotate around the center where one vertex lands on the other one? Yes or no? And this one, yes, it does have rotational symmetry. And if I try to rotate this one, even if I try to get this to land here, because they're different angle measurements, it wouldn't line up. So that'd be no, it doesn't. Now, it asks for any rotations. What we do is you want to talk about how many degrees did we change? That's this right here. So what you do is you take 360, which is a whole rotation, and divide by the number of vertices. And it tells you that because I want to break 360 degrees up into five different angles. So 360 divided by 5 is it has 120-degree rotational symmetry. So our answer is yes, and every 120 degrees it lands on itself. All right, there are your notes. If you have any questions, reach out. If not, we'll see you in class or the next video. Have a great day.